Hello everyone, my name is ShengLin from Science New Zealand. So on behalf of our research team from NIWA and GNS, I would like to take this opportunity to thank for the invitation to participate in this workshop. And it's our pleasure to give you a brief introduction of our post-disaster damage survey work in New Zealand and overseas. So here is the outline of my talk today. So first I will quickly brief the background of post-disaster damage survey, what's that and why it's important. And then I will introduce you the end-to-end data management system we developed in GNS. And I will take you through some example how we use the tool to create the exposure data as well as conduct post-disaster damage survey. And in addition to the data capture tool, I also want to show you some technology like the drone we use to support our understanding of the natural disaster. And I will quickly conclude with some few bullet point summary. So introduction. So as we all know, we cannot prevent the happen of a natural disaster, but we would like to build a disaster resilience community. So when the disaster happens, we can minimize its impact. So to achieve this goal, and when the disaster happens, we need to respond immediately and accordingly. And we also need to recover quick during the post-event and have some plan before the event happens. And to support this decision, we definitely need some data. So for example, we need to know where the building, the infrastructure are located, what's their age, the material, and what's their condition. And similarly, for people, we want to know where people are they at home, in the office, or on the street, and what's their age band and gender proportion, etc. So in addition to this exposure information to support the pre-event planning and the modeling, we also need to collect the post-event damage data to support our understanding of the building performance. So obviously, the role of data is crucial and we need to capture them. So traditionally, we record a building attribute in the field, use paper and pen, and then we turn all the information to the Excel spreadsheet. And as you can imagine, this is a labor and a time-consuming activity. And it's very likely we will make a mistake when turning all the information from paper to the spreadsheet. And also you need to bring many gear like the pen, paper, camera, GPS, battery, etc. during your field trip. And fortunately, with the rapid development of the new technology in recent years, many research groups have developed many data capture tools that can be installed into a smartphone or tablet. And by taking advantage of the GPS and the camera function on board, the smartphone or tablet can record all the survey data in a digital and efficient way. So here is just some example of the non-commercial product of data capture tool. So for example, the FEMA rover tool, the GIM, the global earthquake model inventory data capture tool. Also the Kobo tour bus, quite popular in the Pacific. And the MAG tool, recently developed by the NGA, the National Geospatial Intelligence Agency. And in GNS built on the GIM capture tool, the open source feature, we improve the function of the data capture itself. And on top of that, we also build a central server and a web portal to make it more friendly and more efficiently. So, and we call end-to-end data capture data management system. So as shown in the image here, we collect the data, use React in the field, and all the collect information was synchronized and archived in the central server and ready for people to edit or use for many purposes like the ASA management or risk modeling or damage assessment. So similar to other app in your smartphone, after you launch the React, you will have the background map to determine your location. And once you locate your survey subject, then React will take you through all the survey form. That is very similar to what you often see in the paper format. And as you can tell, the layout of the React is quite similar to the gym capture tool, but I will show you some improvement we made in the next slide. And also built on the internet connection, either through Wi-Fi or mobile network, all the client information was synchronized to the fields to the server. So the people in the office can track the field activity and also make some decision use this timely information. So as I mentioned, so we made some improvement to the React. So the first one is we create some communication between the capture tool and the server, so they can talk to each other in a real time. And also different from the gym data capture tool, in gym's tool, all the attributes are hard code and only designed for earthquake purpose. In React, we make the survey form more easily editable, and people can just modify to text file. So the survey form can be modified for different hazards like the tsunami, flood, volcano, or cyclone. And then here is the image to give you some idea of the structure we create for the inventory server. So I think that's after a quick and brief introduction of our end-to-end data management system. In the following slides, I will take you through some example. We use the tool to create the exposure data as well as post-event damage survey, both in New Zealand and overseas. And the first one here is a field trip we had in Vietnam. So the purpose for this trip is to create the exposure data set to support our consequence impact modeling to the downstream community caused by the dam failure. So with the support from the local university student, we are able to collect some typical building attributes in Vietnam and also record people's experience from previous event. And during this mission, we are a group of 11 people with 4 tablets, and we spent 4 days in the field. And we collect over 700 buildings and use the React tool. And ideally, we want to capture each individual building in the study area, which is estimated around 60,000 buildings. So as you can imagine, it will take up to a year or more to cover the whole area. So to create the exposure data for the whole study area in an efficient way, we developed a technical approach to populate the large-scale exposure data set. Use the sample building we survey in the field along with local specific mapping scheme and other available data set, for example, the building footprint, the national census data, etc. So for comparison purpose, the computing time for this automatic step only take about 10 minutes to populate all the exposure for the study area. So here it just give you some idea how we create this exposure information. And Kaikoura earthquake. So as you know, on the 14th of November 2016, moment magnitude 7.4 earthquake hit the Kaikoura area in New Zealand and caused widespread damage to both building and infrastructure. So by working with emergency people from the local government and also engineers from industry, we surveyed the damaged building and infrastructure. And all this record damage along with the instrument shaking intensity will improve our understanding of the building and infrastructure seismic performance during the earthquake shaking. And the next one is the earthquake and tsunami damage survey in Palu 2018. So in 2018, severe earthquake and tsunami destroyed many buildings and caused more than 3,300 fatality in Indonesia. So 7 weeks later, we flew to Indonesia to measure the tsunami flow depths as well as record the damage level to building, road, and electricity network. And we record different damage level based on observed damage, and also we record some key attributes of the building portfolio in Indonesia, like the use category, the material, the ground floor height. And again, all this information will help us to understand the performance of the building in Indonesia during the earthquake and the tsunami event. And as I mentioned previously, React can be adapted for different hazard purpose. And for this case, we use React to capture the wind damage during the cyclone Winston hit Fiji in 2016. So again, work with the local research people. We collect the structural and non-structural damage caused by the wind damage. And also we try to record the building habitability and the business interruption by talking to people in the community. And again, all this information will help us to understand the wind vulnerability for the building in. And landslide. So couple of months ago, there's a severe storm event occurred in the South Island, New Zealand, which will trigger many landslides. And here is just one of many most badly affected buildings during this disaster. And this is some typical image we would take while we do the survey on the ground. And if you look carefully at this image, you might or might not notify that this was originally a 2-story house, and the ground floor was took by the landslide debris, and now the up floor just sit on top of the ground floor. And now you might wonder, how could this happen? And to understand the cause of landslide and its consequence, we flew drone over the area to see the extent of the landslide impact from the air. So here is just the drone image just from the top of the house, the damaged house. And if we flew further away from the house, we now have more idea of the extent of the landslide impact. And as you can tell from the image, the debris affect more than just one house. And then here is another drone image that will help us identify the source of the landslide and also the estimate of the volume of the landslide debris, and have a great understanding of the source of the landslide and the impact to the building in the area. So conclusion. So just today I just quickly take you through the end-to-end data management system we developed in GNS, and also show some example how we use this tool to create exposure and do some damage survey both in New Zealand and overseas, and also show you some drone image we take during the event to support our understanding of the impact from natural disaster. So I think that's a quick overview, and that's all for me. And please feel free to contact if you have any question. And I am looking forward to meet and discuss with you guys during the workshop in a month's time. So thanks again, and bye-bye.